Today we're going to talk about sine and cosine graphs, but now we're going to talk about a more general name for them, and that is a sinusoidal function. So sinusoidal function is just a sine or a cosine function. Now I'm going to talk about four characteristics that sinusoidal functions have. So number one is the sinusoidal axis. That is the horizontal line that divides the sinusoid in half, or the equilibrium point of a sinusoidal function. So down here, in this case, it's going to be the x-axis. So this is the sinusoidal axis. In this case, it's y equals 0. The other characteristic that goes in the y direction, or the vertical direction, is the amplitude. And the amplitude is the distance between the sinusoidal axis and the maximum point of the function. So this is called the amplitude. There's also two characteristics of a sinusoidal function in the x direction. One of them is called the period, and that is the number of units on the x-axis needed to complete one cycle. So if we were to draw a line from here to here, this being the starting point and the ending point of the cycle, that would be one period. So it's the length of one cycle. So notice that is the difference between the starting and ending x value of the cycle. Now, we're going to talk later more about frequency, and I'll give an example of that, but frequency is the reciprocal of the period. So here we say the period is number of x units per cycle. Frequency is the number of cycles per x unit. Example, 100 cycles per second, which is hertz in physics, is an example of frequency. The fourth characteristic, which is also in the x direction, is the phase displacement, or the starting point of a cycle. The x-coordinate that marks the beginning of one cycle when the graph is shifted left or right of the origin, or the horizontal displacement. So right now the graph has not been shifted left or right of the origin. This is a sine graph. So right now x equals 0 is the phase displacement. So there's really no displacement yet. We haven't moved it off of its original spot, but we would still say that would be the starting point, then would be 0. So let's look at these four characteristics on a graph now that has been moved off of the origin and moved up and down. So when we look at these four characteristics, the first thing we're going to start out with is the sinusoidal axis. That is the line that cuts the graph in half vertically. So it's a horizontal line, but I'm saying the graph has the same amount above and below that line. So let's look and see. The highest point that we go is 1 on the y-axis, and the lowest point is -5. So here's a high point and a low point. So halfway between the high point and the low point would be where the sinusoidal axis is. So the sinusoidal axis here is y equals -2. The next thing we're going to look at is the amplitude. The amplitude is the distance between the sinusoidal axis and the high point, or the difference in these two values here, which is 3. So the amplitude equals 3. The next thing we're going to look at is the period. The period is the distance from the starting point to the ending point of a cycle. Well, the sine cycle starts on the sinusoidal axis and it ends on the sinusoidal axis. And then it goes up, down, and back up again. So the starting point of the cycle would be 3, x equals 3. The ending point of the cycle is x equals 23. The distance between those two values is 20 units. And so the period is 20. The phase displacement is the starting point of the cycle, and we saw that, and that's in the x direction, so the starting point of the cycle is 3, so that is the phase displacement. and that is an x value, x equals 3. Notice that sinusoidal axis, sinusoidal axis and amplitude both have to do with the y direction. So usually I do those first, and then I do period and phase displacement next, and this has to do with the x direction.